Section 11.7, we're looking at our surface area and volume of cones. Right? So for our cone, right, our surface, our central question is how can you find the surface area and volume of a cone? Okay. Our formula for surface area is pi r squared plus pi rl. So remember, surface area, we're looking at covering it. So pi r squared is our circle that we have in the cone. The pi rl is the slant stuff that comes up. Right? R is just our radius, pi is pi, L is the slant height. Okay? The slant height is looking at this part here. Okay? Also realize this only the surface area only works for a right cone, where your height, the actual height, comes down and hits at 90 degrees. We're not going to look at any that that aren't right, so it's not a big deal. But this doesn't work for a cone that is slanted. So, looking at our examples here. Example 1, find the surface area of the right cone. So A is as simplistic as they can get it. They give me my radius, they give me my slant height, I plug those into our formula. So we have pi r squared, which is 3 squared, plus pi times radius times slant height, which is pi times 3 times 5. I get 9 pi plus 15 pi, which is 24 pi. Okay. And again, you can leave your answer like that. If you multiply it out, you get 75.40 meters squared. And this is area, so your unit should be squared. Right. Then on example B, they make it more complicated. We still have the radius, but here they give me the height. That height is not what I want. I want the slant height out here. So we need to do Pythagorean theorem to find that. 5 squared plus 8 squared equals my slant height. Square both of those, add them, take the square root. I get my slant height is 9.43. So now I plug that into my formula. Pi 5 squared gives me my circle, plus pi times 5 times 9.43 to get my part that goes around here. I have 25 pi plus 47.15 pi if I multiply that out. However, this has been rounded, so that's not exact. So here we're going to want to multiply it out, which is why you see me have 148.13 here. Multiply 25 pi out and add those together. I get 226.67 feet squared. Example C says a right cone has a diameter of 1.8 inches and a height of 3 inches. All right, so here they're not giving us the picture, we're thinking things out. So first realize they give me the diameter. That is not what I want. I want the radius. Easy fix, I cut that in half. That's where this 0.9 comes from in both of these. That is my radius. Then again, they give me the height. That's what we just looked at. So I need to do Pythagorean theorem to find my slant height. I'm doing Pythagorean theorem with the radius and the height because the diameter keeps going. The radius is what stops at the center. So that's what I'm using for my formula. Go through and solve this. I get a slant height of 3.13. So I have pi times 0.9 squared plus pi times 0.9 times 3.13. Realize when you square a decimal, your number gets, if it's not a whole number, it gets smaller. All right. So 0.9 squared is 0.81. So I have 0.81 pi plus 8.86. All right. So when I add those together, I'll get 11.40 inches squared. Next thing we're looking at is volume of a cone. All right, volume of a cone is the same as the volume of a pyramid. Difference is our base doesn't change, just like the difference between a prism and a cylinder. All right. So 1/3 area of the base times the height, but my area of the base is always going to be a circle, pi r squared. Okay. This works whether it's a right cone or not. So if I was looking at surface area, I could find surface area of this one. I could not find surface area of this one with the formula we used. With our volume formula, I can find the volume of both. Also watch if you're switching back and forth, right? Volume, we're looking at the actual height. We just looked at surface area, that was the slant height. They're two different things. So this height is here. So looking at some examples of this. Right. Example A, they give me everything I need, 1/3 pi r squared times my height, radius being 9.5, height being 16.8. Multiply that out, I get 505.4 pi, which is 1,587.76 millimeters cubed. Right. B, they decide to make difficult on us, and they give us 62 degrees and a height and no radius. So here we're back to trig functions. Right? We have our opposite and our adjacent. So we're doing tangent. The tangent of 62 equals 12 over my radius. Right? So I do 12 divided by the tangent of 62. I get 6.38. So now I plug that in for my radius. 1/3 pi 6.38 squared times 12 gets me 162.82 pi, or 511.51 meters cubed. Then looking at C and D. C is fairly straightforward. Right now this isn't a right cone, but we're finding volume, so we're fine with that. They give me the radius, they give me the height. 1/3 times pi times 4.5 times 12 gives me 81 pi, or 254.47 feet cubed. D is a composite shape. We have a cylinder and we have a cone on top of it. So I need to find the volume of both of those. So the cylinder is area of the base times the height. My base is a circle. So pi r squared times the 7, that is the height. I'm then going to add that to the cone that's up top, which is 1/3 area of the circle times the height. So pi 3 squared times 3. So the cylinder has a volume of 63 pi. The cone has a volume of 9 pi. Add those together, I get 72 pi. Multiply that out, I get 226.19 centimeters cubed. Okay. Then example 3 and 4 are looking at similar shapes. Okay, so remember, scale factor A to B, area A squared to B squared, volume A cubed to B cubed. So when we're looking here, it says the two cones are similar, find the scale factor. So if 108 pi to 256 pi, right? So I make a fraction out of that. The pi's cancel, which is nice. So I have 108 to 256, reduce that. When I reduce this, I get 27 to 64. That's the ratio of my volumes. So to get the ratio of my side lengths, I take the cubed root. The cubed root of 27 is 3. 3 times 3 times 3 is 27. The cubed root of 64 is 4. 4 times 4 times 4 is 64. Okay? So this then is my scale factor. Okay. Then on example 4, we're finding the volume of cone B in both of these. Okay. So they give me the volume of A. So in example A, this is 72 pi millimeters cubed. They also give me the radius, 9 millimeters and 12 millimeters. So if I set 9 to 12 up as a ratio and reduce that, 3 to 4 is the ratio, my scale factor. Since I'm dealing with volume, I need to cube that. So I have 27 to 64. I set that up as a proportion with my areas, the 72 pi and the volume I'm looking for. Cross multiply, I get 27y equals 4,608 pi. Divide by the 27, and I get 170 and 2/3 pi, or 536.17. Do the exact same thing on the next one, just with different numbers, right? Well, they give me the heights, so they should match up as well. So 2 to 4 reduces to 1/2. I cube that. 1 cubed is 1, 2 cubed is 8. Set up my proportion. Now here I have my variable in a different spot, because here they gave me the volume of the larger one, right? And I put my larger number on the bottom. So where my variable is changed, but I still cross multiply. 8x equals 28 pi. Divide by the 8, I get 3.5 pi, which when I multiply that out is about 11 inches cubed. And that is our surface area and volume of cones.